released for the EXO platform, something we've been developing for a few years now. And what it is, it's a brand new LED technology that we miniaturized in order to be able to integrate it into an existing EXO system or a new EXO system. It's designed for long-term nutrient monitoring in freshwater environments. Like I said, you can add it onto the EXO, which makes it really nice in terms of cost. If you've ever looked at some of the other nitrate monitoring sensors on the market, you know, they can be pretty pricey, but this sensor runs about $5,000 and you can put it onto an existing EXO. If you're looking at an EXO system from scratch, buying a brand new one, in addition to the sensor, you're still going to be well under some of the optical nitrate monitoring technology that's out there. And it just makes this sensor the most accessible nitrate sensor out there. Oftentimes, with some of the other sensors, you have to send them back into the factory for calibration and maintenance. The user is able to do all the factory calibration and maintenance right there on the spot. So it makes it accessible, easy to use, really brings down your overhead costs and also any downtime that you might need for sending in equipment to the factory for calibration and maintenance. So how does this sensor work? We have two light sources up here on the top end of this sensor, and one is emitting at 235 nanometers. Another is emitting at 275 nanometers. The primary LED is measuring nitrate as nitrogen. And the second one is trying to detect any natural organic matter that might cause interference with that measurement. Both of these light sources travel through water in this 10 millimeter sample path and are measured right here at the photodiode. We recommend that users pair the nitrate sensor with a turbidity sensor so that there can be real-time turbidity compensation as well. And we can eliminate that kind of interfering with our data. But we have a really in-depth tech note that describes the science, kind of how we do those adjustments and those offsets. So if you really want to nerd out and dive into that information, that's available on the NitroLED product page. What's necessary to get you started, right? So let's say you have an existing EXO system, an EXO 1 even, without any sort of central wiper. All you would need is a turbidity sensor and a conductivity sensor. The sensor we're showing here is the wiped conductivity sensor, but you could similarly use the traditional conductivity sensor that we have, and then you'll need the nitrate calibration solution. If you want to do continuous monitoring with an EXO 2 or an EXO 3, then you'll also need the EXO central wiper. And then you'll want to purchase the EXO NitroLED kit, which is going to come with this alignment ring that you see down here, as well as this new wiper brush. So if we're to kind of compare what our traditional system looks like fully loaded versus what the new NitroLED sensor looks like with this new NitroLED kit, you can see this new alignment ring is obviously a newer kind of feature that we have here, and the brush is a lot different as well. So the brush on the old sensor is just a down-facing brush that wipes the faces of all the sensors. But now what we've done is we included that same brush technology that you're familiar with, and we've also included this this new brush here that has kind of an upward and down-facing brush. And this is designed to measure the light source, or I'm sorry, to wipe the light source as well as the measurement diodes down here. So it's a hybrid, right? We were able to use kind of that old high torque motor with a really reliable wiper and add another wiper on there and get some, you know, a little bit more enhanced wiping for this new sensor and the same kind of quality of wipe that you're seeing there. This alignment ring also is a nice addition, even if you're not using this NitroLED kit. In the past, we've recommended that you use like a zip tie if you need to use this wipe conductivity sensor. So this is a much more elegant solution, and the probes tend to just hold a lot better. It's easier to maintain, and it looks a lot better as well. So jumping to the specifications of the NitroLED sensor, most of you probably want to know what's the range on that. So the measurement range is 0 to 10 milligrams per liter. This is a pretty conservative number. In field testing, we've been able to double that, so we're upwards of 20 milligrams per liter, and we've compared that against some of the other UV nitrate sensors. It tracks very well. The accuracy range is 0.1 milligrams or 0.4 milligrams over the entire temperature range of the instrument. We also have a really low detection limit of 5 thousandths of a milligram per liter. And in case you missed it, with the pandemic and everything going on, like I mentioned, we added rhodomine to the EXO platform. So for those of users who have an EXO sensor and you're looking at doing some dye tracer studies, some mixing studies, even some type of flow measurements, this is a real nice option. I think the unique thing about this new rhodomine sensor is that it's a dual channel sensor. And the reason we did that is because you lose a little bit of accuracy on the low end and the high end if you try to cover a full range of 0 to 1,000 milligrams per liter. So what we did was create this new dual channel sensor that does really well on the low end, great in the middle, and then this other channel that measures really well on the high end and then great in the middle as well, just to make sure that you're getting really high accuracy on the extremes of your dye tracer study events. So what does the accuracy look like? What's the range? This will measure from 0 to 1,000 milligrams per liter. It has a minimum detection, micrograms per liter. It has a minimum detection limit of 100th of a microgram per liter, and then an accuracy of 0.1 micrograms per liter. The Pro sample is not a brand new addition to the YSI offering, but we've made a lot of enhancements on it that I think are worth bringing up. It'll come in two different models. So we have a full-size model. It's kind of what you would expect. You can have 24 1-liter bottles in there, or one composite bottle in there. It can come with or without a distributor arm. And we also sell this mini version. This is only for, like, I think it has a 10-liter composite sampling jug in there. So you have these two options of, do you want the full size or do you want a miniature version? And then we have these kind of features here where you can include SDI 12 in it, or you can have it without SDI 12. And so what's the point of having SDI 12 connectivity? The nice thing is that you can start to integrate a lot of the sensors that we offer, as well as sensors from other manufacturers that are SDI, communicate via SDI 12. In our case, the EXO is a good example. If you want to use some event-based sampling, looking at water quality, then you can set parameters in the actual Pro sample that will read the SDI 12 instrument and then trigger samples based on turbidity, conductivity, temperature, whatever you're looking for, and make sure that you're sampling at those crucial water quality events. In addition to that, standard, it's going to come with 420 milliamp analog sensor inputs, some digital sensor inputs. And what's really important about this new auto sampler, and what we really focused on, was this new peristaltic pump, which delivers really high sample volume accuracy. So we did a lot of testing against some of the bigger manufacturers and just try to make sure, are we able to pump enough vertical distance? We definitely exceed in that category, and then volume accuracy. And if you guys ever want to have a better look at that, we have a lot of data on kind of what those comparative studies look like. Just to go over some of the basic features, it's pretty intuitive, a nice little keypad, simple kind of directional menu, just easy to learn, easy to use, pretty low maintenance. All you really need to do is just change this peristaltic tube pump. It'll come with one already, and then you can just order them as you need them. And then it's just a nice compact design. It's really easy to handle, especially the mini one. It's pretty lightweight, has some nice handles on it, pretty tight, lockable, everything that you'll need. And it has it's double walled, so we don't have a refrigerated version, but in the case that you need, cooled samples, you can put ice packs in there or wet ice, and the insulation holds really well, holds that ice really well. And lastly, we're going to cover the Sontek RS5 Mini ADCP. So I actually brought one of these just to show you the size of it, right? So I'm not sure if many of you are familiar with an ADCP, but our classic model, which is the M9 ADCP, it's our full featured model. We released it, I want to say 2014, is about the size of a roll of paper towels. And it also comes with another box, which does all the power and communications. And so what I really want to highlight here is that we've been able to condense all that technology into this small little soda can sized ADCP. And so how's this system different? We changed the type of signals we're using in this technology, or I guess improve them. So now we're using a broadband transducer, which is a little bit different than our classic ADCP technology. We're still incorporating smart pulse, And what Smart Pulse does, just to kind of simplify it, it reads the water, determines, what the signal quality is, how fast the water is moving, how deep the water is, and then it kind of selects the best type of signal that's going to give the highest accuracy and highest resolution for the water you're measuring. So if you were just to use a single channel and move it across, from one bank to the next, you might need to tweak the frequency just a little bit. In the past, you would actually have an expert who knew how to operate this thing and how to make those tweaks on the fly. But this instrument through Smart Pulse does that on the fly for you, which makes it really reliable and makes it so that most entry-level users can collect data with a good amount of confidence. It's optimized for ultra shallow conditions. So I think on our last instrument, maybe 8 inches was probably about the lowest you could go reliably. Now we can get down to 4 inches. It's a very small board, as you guys can see here too. This is our full size board, and this one's about half the size now. So for some of those really narrow channels or kind of narrow streams where you wouldn't want to put the big ADCP anymore, this is really going to fill that gap well. And it's actually going to go into some of the territory where you might use a weighting discharge measurement system. So instead of using that weighting system, now you can actually use an ADCP and get the measurement done a little bit faster with some higher resolution data. Bottom tracking has been greatly improved because we're using broadband. And for those of you who aren't familiar with what bottom tracking is, as the instrument moves from one bank to the next, it actually reads the bottom surface and the textures to tell how far it's moved over laterally. So you move this instrument from one bank to the next, it measures the ground, how deep the water is, it measures the water velocities, and then it calculates the flow. But it's really important for the instrument to read the bottom accurately to determine how far it's gone across a channel. That way you're not going to skew what the actual area or the distance across a channel is, because that's used in the flow calculation. So this broadband has really improved our ability to read that bottom, get a really accurate picture of what's going on the bottom, but also that distance in that area will be very consistent and reliable. The range on it is surprising. So we talked about you can get down to 0.3 of a feet, about 4 inches, but you can also get to about 19 feet of depth. So this should take care of most of your large rivers and most of what you need to measure. It's got a great range. And if you ever needed to size it up, you can, because the water's a little bit choppy or the conditions are a little rough, you can always put it on one of these boards with an adapter that we're also selling. And lastly, the Rivers, the RS5 software just has a very intuitive and familiar feel. So even if you haven't used Sontek's equipment, let's say you've used software from a different manufacturer, you're still going to be able to go through this, set it up pretty easy, and everything's going to be pretty familiar and intuitive. So we really focused on making sure that the software was easy to use. And we'll dive into that a little bit before we wrap up. So what does the hardware look like on this? It has 5 beams, as you can see here. This middle beam is used for the vertical beam, so this tracks depth. And then the other 4 beams profile velocity. Like I talked about, all the electronics, what we used to use in terms of power, communications, processing, memory, it's all in this package now. Everything's in here. We have a small little port we can unscrew here, and we slip a lithium-ion battery pack. It's usually good for about 7 to 8 hours of continuous use, and you get 2 of those batteries with each RS5 system. Lastly, we have a little GPS connector here. We sell a GNSS GPS antenna for this system, but you can also use an external antenna as well, as long as it has the right data stream. So how does the data stack up? These are 4 of the main systems out there right now. We have the M9 River Surveyor system. We also have the S5 River Surveyor system, which are from Sontek, and then something like a Stream Pro, which is pretty familiar for a lot of ADCP users. And as you can see, the data quality, this is a decent site where we measure. It's a test site out in Yuma. It's really high. This is the RS5 data. You can see the resolution on the data is just a lot better, even than our full featured system for most of the transect. So again, those broadband transducers really help out a lot. The size of it, again, makes it really easy. You can fold down the antenna mast. And this is a new bag with it that comes with it. You can see there's a little hump here. So when you fold down that antenna mast, you can just pop it in the bag, put your backpack on, and keep on moving to the next side, or throw it in the back of your truck or car, whatever you got going on. And then this is just a comparison of the 3 different boards there. A couple quick snapshots of the software. One nice thing, you can do these KML exports so that you can open them up on Google Maps and actually see where the transect was on a Google map. And just to wrap up, here are some resources. I'm not sure if you can jot any of this down real fast or take a look at the presentation later, but we do have a virtual demo of this here on the website. And we also have a quick start video, which kind of walks you through setting everything up from unboxing to taking a measurement and reviewing data. So I want to thank you all for sitting through this presentation. Really appreciate you showing up. Feel free to stop by the booth if you have any questions, or we're going to open it up now.
He'll be doing smart sensor technology on water quality.
Thank you. Thank you. Good morning for everybody, and thank you for being here with me this morning. I'll present you quickly a range of sensors embedded with smart technology, and let's start a little bit with
click that on the laptop first for some reason.
We'll start a little bit with a presentation of the company quickly. For those who are not familiar with us, we are a French and European manufacturer. We've been on the market for more than 40 years, and we've got 4 production sites in Europe, and everything is made 100% in-house, so we have full control on quality control and of the production. We go to the market as an OEM manufacturer mainly, and we also are using distribution and representative worldwide. We are present in more than 55 countries around the world. Here in the US, we work with Geotech as our representative for the market. So a general feature of our sensors, they are smart. I will show you and explain you why exactly. They are 100% digital and universal, and we've got a wide range of parameters for multiple applications depending on your needs. Why are they smart? All the calculation, all the intelligence is inside the sensor. We have internal calculation of compensations embedded, like temperature or pressure or salinity field. We've got a full auto diagnostic running inside the sensors. We've got automatic recognition over the network if the sensor is connected to a digital network. All the calibration history is stored inside the sensor, so you have access to all the different coefficients that has been used and all the history of the calibrations. Also, the users are stored, so you can know who's been calibrating the different sensors. So with this, we have a really high reliability to the measurement. All the treatment is inside the sensor, so we have no third party, no calculation outside of the sensor. We've got 2 digital protocols embedded, available with all of our sensors. It's not an option. They come directly with both protocols. They come with SDI 12 and Modbus. So we give all the information for you to integrate this. It's 100% open. You can connect the sensor to whatever third-party system, and it's really easy to integrate. You can have very long cables. There's no signal loss. It's a digital signal, so there's absolutely no problem about the quality of the signal. And you can control remotely the sensor. We have a wake up and sleeping mode that is allowing us really to have very ultra low power consumption. So we've been able to achieve very interesting application in IoT and in application where you have no energy. Basically, we can power everything with just a single battery. So we can interconnect the sensor with everything we want. Basically, we've been using successfully the sensor with data logger or PLCs, with a process controller, with networks, and directly tied to PLCs, for example. We have very nice applications now in IoT and telemetry as well. And we also have a handheld equipment and data logger that can help you to use them in the field. We are a company that is originally coming from the wastewater business. So all of our sensors are really rugged and resistant for harsh environments because we mainly tested and developed our sensor thinking about that kind of harsh environment. So we've been also using them in underground water with success here at Geotech and with other customers worldwide. We are working a lot in the industrial business, in discharge control, and also process water like cooling towers and that kind of applications. Superficial water and reservoir and rivers, lakes, etc. We've been using the sensor very successfully as well. And a big business for us is also aquaculture and fish farming. So let's dig into the range. This is our first and the sensor we sell the most. That's a DO sensor. We only manufacture monoparameter sensors that will really fit the need when you don't need a big multi-parameter platform. So that's a low-cost solution, high quality, and you really get for your money with selecting the parameter you need. So the DO sensor comes in two versions. We've got titanium for harsh environment and seawater. We've got a stainless steel version for general application when we don't have really a big concern with corrosion. The measuring range is 0 to 200 in saturation, and we also calculate the concentration with internal calculation of compensation of temperature, atmospheric pressure, and salinity. The calibration is really once a year because it's really stable. You do a calibration in the air. It's one-step calibration, and every 2 years we will have to change the consumable, which is the optical part, the disc of the sensor, and then we'll do a 2 points calibration and we'll be going forward. We also have external wiper system. If you need a long-term deployment or if you are using the system in process such as wastewater, it's a good idea to have the wiper installed because it will keep your optic clean and then you will have a very stable measurement over time. Very low consumption, that's a characteristic all over our sensors. So we've had the consumption in standby in microns, so it's really useful when you are using it with a dial layer. So next sensor, that's also an optical one, NTU sensor. It's nephelometric. We've got two independent ranges or an automatic range. So we've got 0 to 50, 0 to 100, 0 mil, 1000, 0, 4000 NTU. Each range is separately calibrated, so you can work in the range you are interested in, or you can set the sensor in automatic and it will automatically recognize where it has to, which range it has to use. You also can calibrate this sensor in suspended solid, 4,500 milligrams per liter. And this is useful in sludge applications, sludge recirculation in wastewater, for example. That's a very stable sensor. It's optical, so while it's clean, you will have no drift on the measurement, really. So we really advise you to use the wiper with this sensor because if you don't wipe it, once it gets a little bit dirty or you've got some particles over the sensor, and you have easily a drift of the measurement. So try to keep it clean, it's really important. This is a suspended solid sensor. So this is for the higher range. That's an higher absorption sensor. We use the 870 nanometer wavelength. We can, the range is up to 50 grams per liter. That's really a high range, which is around 40,000 milligrams per liter. So we are speaking about sludge and very high range of suspended solid. The sensor also provides a measurement in turbidity up to 4,000 FAU. That's not NTU because we are not compliant with the nephelometric measurement. That's a 100-degree measurement. That's not 90 degrees, so it's not NTU. There is an equivalence with the FEUA and NTU. We also give you an information in percentage from 0 to 100. This is really useful for sludge interface when you want to identify the level of the sludge in a decanter, for example. So you'll be very close to 100 of transmission when you're in clear water, and then the measurement will drop once you reach the sludge. So this replaces a manual reading of the depth of the sludge. You can do it with this sensor. Nearly no calibration as is optical while the sensor is clean. There will be very little drift onto the reading. Absolutely no consumable. We just keep it clean and it will work with our own product. So this is the last of the family of geotechnical sensors. That's a UV 254 absorption sensor. So with this sensor, we have the absorption coefficient in UV 254. So we can calculate a good correlation with global parameters such as COT, BOD, or COD. How does it work? Basically, we have an optical path, two versions, one with 2 mm and the other one with 50 mm, 2 mm for wastewater and 50 for clear water or potable water. So we will measure the absorbance in UV in this path, and this is highly proportional with the dissolved organic matter present in the sample. We need to apply a compensation for suspended solid or turbidity because if you have some particles or sediments inside the water, they will also absorb UV inside the optical path, so we have to compensate for that. That's why we have a lead at 530. And you will have to grab some samples to calibrate your sensor. It's really for process applications, because the correlation is process depending or matrix depending. So we take some samples, we go to the lab, then we got some lab result in the parameter you're interested in. We drew a correlation curve, and then we enter the coefficient of the curve inside the sensor. So, and then afterwards, we got a calibrated sensor onto the process. And being optical, it's very important to keep it clean. So we don't have a wiper directly, but we use an air blow to keep the optical parts clean. There is an external port available for you, so you connect a compressor network, and with a solenoid valve, you activate some blowing over the time, and you keep the sensor clean. So now electrochemical sensors. This is a pH ORP combined sensor with temperature, of course, because we have temperature compensation. What makes it different from other sensors on the market is that it's built in two parts. So I have one with me here, so you can see that we have the electronical part of the sensor and the consumable on the other hand. So this is the electrode that will be changed over time because the electrode will consume itself and we don't refill the electrode. We use a jellified plastogel electrolyte, which is really stable over time and doesn't contaminate really easily, so that's an advantage. But once it's wasted, we change the electrode. We keep the electronical parts. So it minimizes the waste and it optimizes your overhead cost. You can have from 2 to 5 calibration points with this sensor. And the electrode is really stable over time. We've used it really successfully in process application 24/7, 1 year without any problem. So it lasts very long. If you use it for spot measurement, you can even change the cartridge every 2 to 3 years. So it's really stable over time. Based on the same platform, we've got a specific ORP for process sensors. And the main difference is that we have a big annular platinum ring that allows a very big contact surface with the water. So it's really stable over time in process conditions. And the main application of this sensor is an anaerobic process in wastewater treatment plants. So we will measure the the anaerobic degradation of the organic matter thanks to this sensor. It uses the same plastogel technology for the electrodes, which make it really reliable over time. Now that's a conductivity, salinity, and total dissolved solid sensor. Same philosophy as the NTU, 4 ranges, automatic selection of the ranges, each range calibrated independently, so you can select the range you want. Two pairs of electrodes, one for the measurement, one for the compensation, so you've got a fooling compensation onto the sensor. It makes it very stable over time for long deployment, for example. We also can add an anti-fouling with copper onto a sensor to keep it a longer time without drift in the measurement. For all of our sensors, I didn't mention that you can use whatever value of buffer you need or conductivity solution. It's not pre-selected, it's really user selectable, so it's according to your need and in which point you're going to be measuring during your campaign. No consumable, keep it clean, and it will be working without any problem. We've got a toroidal sensor, very good for harsh applications when you have a lot of food fouling or also sludge or mud, discharge control, long-term deployment in seawater. It will work very well, no drift, even if it's really dirty, it will keep on measuring without any problem. The range is up to 60 PSU and absolutely no consumable with this sensor, really for hard application. We've been using it in seawater, in salmon aquaculture with very interesting success here. So it's really a sensor that lasts very long and it doesn't drift. So now let me show you two examples of application with this sensor that we are also providing. We've got a handheld equipment that has been designed more like a data logger, really. It has the ability to connect all the range of sensors we've seen previously. So you have a really broad range. You can use it in many applications. We've got a very high autonomy just with the embedded batteries, up to 10 days with 1 measurement per minute. We also can externally power the handheld and get up to 1 month, so you've got a big memory. And we've got 100,000 memory points, so you can really have a long follow-up of your data up to 1 month, and you can retrieve the data by extracting it and then process it the way you need or the way you want. You can use 2 sensors of the same parameters if needed, 2 pH sensors, 2 DO sensors, that's no problem, or up to 4 DO sensors, so you can have multi-point points monitoring at the same time with this unit. And it's really rugged for application in the field, so you'll have no problem. It's IP67, so that means that it's watertight, and you can use it in any condition in the field. And last but not least, now that you've seen that we have ultra-low power with all of our sensors, we are developing an IoT technology. So we have a module that has a LoRaWAN communication. That's a radio communication that allows you to retrieve the data of many sensors at big distances. Up to 5 kilometers is the communication range. And that's the same philosophy that with our open protocols, everything is open. You can integrate to your own infrastructure, to your own LoRa network, using the payloads that we will provide you with, and everything is open. That's very easy to operate the sensor. We have a very simple interface, and that is using a Wi-Fi hotspot, so you can get connected to your laptop or to your cell phone directly to the module, and you can operate, calibrate, and diagnose the sensor directly without any tool, without any software. It's really straightforward and easy to set up. So this is really a nice solution, and you have up to 5 years of autonomy with the internal battery, which is really a nice feature and gives you plenty of time to use the sensor. So that will be all for today. Thank you for being here, and if you have any question, I'm here.
Yeah, I wanted to talk a little bit about the various diameters of your probes. Can you kind of give us a 30,000-foot view of what the dimensions of the sensors are?
Yeah, basically they are like that's this size. It's like 2 centimeters in inches. I don't know. I'm not really familiar with
An American.
your dimensions, but they are bigger than the small sensor we used to see because they are really developed with in mind that they are rugged, so that they are a little bit bigger than standard sensor on the market.
Can you submerge the wiper on the DO sensor?
Yeah, of course, the wipers is 100% submergible, and it's done for application in process or whatever, so there's no problem about it.
That SAC sensor, can you estimate VOD with that?
Yeah, of course. The estimation is really done through the calibration you'll have to do.
What would you calibrate? If I wanted to estimate VOD effluent at a plant, wastewater plant, what would I calibrate?
Okay, so you'll take some readings of the sensor in absorptions, in really directly, the direct parameter that is providing the sensor is absorptions. So you'll grab like 10 to 15 samples and you'll note the absorption at that time. You'll send the samples to the lab and you'll build your regression in between absorption and BOD or COD or whatever parameter you are analyzing. And then you'll get the curve, the correlation curve, and you enter this coefficient inside the sensor to the software that allows you to do that. And then you'll have directly your reading and BOD, and the correlation can be very good. Normally you can achieve like 5% of difference.
So long-term
Yeah.
correlation.
Yeah, exactly. Long-term and real-time. Yeah.
Can you refresh my memory? Did you have a high range conductivity sensor available?
What is high range for you?
I don't know. How high do you go? I'm just curious.
We can go
Periodically.
with the 4 electrodes one up to 200 millisiemens, which is 200,000 micro. And the toroidal is 100 millisiemens, which is normally more than enough for any application in natural water.
Yeah, occasionally, saltwater intrusion applications and stuff like that, people will require a much higher range than is available in a standard, grab sample device. And I think you had mentioned earlier that all of the calibrations are stored in the sensors themselves. Did I understand that correctly?
Yeah, that's it. The last 10 calibrations are available and stored inside the sensor.
And I think when we downloaded last, you had mentioned that you can't reset to a factory cal if you're
all factory calibration are stored in really hard in the sensor. You cannot delete them, and you always can come back to factory calibration.
And that would be something that would typically be recommended if the slope of your calibration, if you accepted a couple bad cals and you weren't as confident in your reading results.
Yeah.
Sure. Okay, thank you.
Can you give me an example of your auto detect recognition?
Yeah. For example, when you connect the sensor to the equipment here, you just perform a scan of the network, and the sensor will reply, yeah, I'm here. That's my address, and
maybe with an auto detect, if you had an error in your data. Early on in your slide, you had something where I took it as there was some error in your data collection. It would do some auto detect or some kind of.
That's more the auto diagnostic.
Oh, that's what it is.
Yeah, we have different auto diagnostic that are running permanently inside the sensor. One is that are you in or out of the range? So if, for example, if you are using a conductivity sensor in that range and the sample comes out of range, you're going to have this diagnostic and you're going to have the information. You also have another diagnostic of the calibrations parameters. If you're out of suitable calibration coefficients, that's diagnostics. And you have the permanent control of the communication as well. If you have a trouble inside the communication, it's going to be diagnostic.
You don't have, it wouldn't do it, let's say you're running like 1,000 microsiemens per centimeter over a period of time, let's say 1,000, 10%, and then you had something like 30%, would it trigger an auto diagnostic?
No, if you're in the range, that's going to be considered as valid.
I think that wraps up our questions. Thanks, Guillaume.
Thank you very much.
Thanks so much. Don't let that team figure out how to do it.
Change simulations. I think it might be.
All right. Hi, everyone.
Hello. Hello.
Hi, my name's Amity Allen. I'm in Regional Business Development with Geotech. Been here for a long time, 19 years. And today I will be talking with you about Geotech Turbidity Meter. More broadly, though, I'm just going to be talking about the principles of turbidity, what it means, why we monitor for it, and how the technology works. So although the presentation is titled Built on Reputation and Made for Field Portability, I wanted to call this turbidity, clear as mud. However, our marketing department shot that down. So why it's not advancing?
You said click the mouse maybe on the laptop.
Okay, so today I'll be providing an overview on turbidity itself, talking a little bit about the methods for analyzing for turbidity. I'll talk about our Geotech turbidity meter and some of its features. And finally, just some tips and tricks for success in analyzing for turbidity in the field. So what is turbidity? Turbidity refers to the cloudiness or the degree of clarity in water. So water that contains any suspended solids like silt, fine organics, and even microorganisms is going to present with turbidity. It can be colloidal, suspended, or it can settle immediately or over time. It's important to note that units of turbidity are qualified as nephelometric turbidity units. I do want to mention that I did have to practice saying that word multiple times before I did this presentation. It does come up a few times, and please correct me if I misspeak later. So turbidity can occur due to natural geology. Usually the turbidity we're looking for in our industry is caused by things like a degradation of water pipes, like that fine example you see there, poor well construction, surface water intrusion. We see turbidity analyzed in a lot of erosion or runoff type applications. Again, there is naturally occurring turbidity with plankton, microbes that you find, small marine life. But for the most part, a lot of turbidity monitoring is done as a result of agricultural, construction, and mining type activities where there's some sort of filtering event going on, and then we're trying to prove that the effluent does not contain more turbid water than we're allowed to provide back into the system. So now that I've talked a little bit about what turbidity is, I wanted to review some of the reasons we look for it, right? Why is this a threat? Why do we want to know what turbidity looks like? So in surface water, high turbidity, it reduces the amount of light that's making its way through that water system, which can have an extremely negative impact on marine life. You see our poor little fish over there. Obviously, it prevents organic matter from growing properly, and it keeps plants from growing. The food supply chain in general can be negatively impacted due to that. And then more directly,
It affects the ability for fish gills to absorb dissolved oxygen. And therefore, in the long term, it reduces oxygen production. I'll talk about that a little bit later, but the actual statistics on that are pretty staggering. In drinking water, high turbidity can be a sign of harbored microorganisms, which lead to gastrointestinal issues that none of us want. So the EPA has very strict limitations on how many NTUs we can see in drinking water. It is important to note, though, that like many of the things we look at in our industry, high turbidity is not indicative of a sick or ill system in and of itself. It's an indicator of other variables that are present that can invite issues with that particular ecosystem. And of course, it can be and often is a temporary condition. So if you have a construction site and a great deal of runoff at that construction site, that in most cases is going to be temporary and that water system can restabilize over time. So now that I've talked a little bit about the biological and environmental effects, I wanted to move on and just talk a little bit about what is high turbidity, right? Because those of you in the industry that have a lot of experience with this are probably very familiar with what these numbers mean, but for those that don't have a lot of experience, it's hard to know what we're looking for and how much variance we can see in a system. So as indicated here, Clear Mountain Stream, 1 NTU, very, very low turbidity. A very large river like the Mississippi that we think of as being fairly tumultuous in the dry weather season, 10 NTUs. Right? Still very, very low relative to some of these other numbers we're going to look at. In a clear, shallow stream, a turbidity increase of 25 NTU decreases the primary oxygen production by up to 50%. So very low NTUs can have a major immediate impact on the health of these water systems. Above 1,000 NTU, primary oxygen production was undetectable. Now, these are statistics that I retrieved from the EPA, but it's important to recognize that these are done in extreme lab condition type analysis, probably. So again, we're capturing a moment in time where the conditions might be a little extreme. So how much turbidity, how many NTUs are we potentially putting out there with our activities, right? Another valid question. So prior to any type of pre-filtration, a construction site stormwater runoff can introduce up to 30,000 NTU. I mean, a huge difference from that 0 to 25 NTU that we already see has a major impact. And that's why state and federal regulations are very, very strict on the amount of turbidity we can introduce into a system. So 280 NTU is the EPA effluent limit for construction activity that disturbs 20 or more acres of land at one time. I actually believe that there's an update on this right now that I meant to put in here that says something more to the effect of 10 acres of land at one time for a construction site that was started after they implemented this, which I believe was in 2014. So big difference between the 30,000 we could be putting in there and the 280 that the EPA will allow at a construction site. So as far as drinking water, very low NTU standards. So systems that use a direct or conventional filtration system, not over 1 NTU, right? Super low amount. And I found this kind of intriguing. The EPA standards say that samples must be less than or equal to 0.3 NTUs at least 95% of the time, right? So this tiny amount of turbidity. But then we say, oh, if you don't have a conventional filtration system, whatever the state says, it can be up to 5 NTUs. So pretty significant difference between 0.3 and 5, but such is the nature of our industry, right? So now that I've talked a little bit about the EPA limits and talked a little bit about how much we see in real world environments, I wanted to describe the technology itself. So here's that word again, right? Let's see if I can do it twice. Turbidity meters use nephelometry. A method to detect particles in liquid samples using scattered light. There's a little bit of trivia I found that I thought was pretty clever from the Greek word nephili, meaning cloud. So you can kind of picture how light scatters off of a cloud. I thought it's always interesting to me to know the etymology of these words to create. So turbidity is related to total suspended solids, and many of you may have experience using a turbidity meter to get a TSS reading, but it's important to note that they're not the same things. TSS is technically a measurement of mass. So you're looking at milligrams per liter in a TSS measurement. What turbidity is showing us is an optical property, right? So we're seeing two totally different things. If you go in and you get a TSS reading from your turbidity meter, you're getting correlative data. It may be highly accurate because the conditions present for both methodologies can be very, very similar, but other things can definitely affect turbidity other than what we would see in a standard, like the mass in TSS. So do be aware of that. The best way to get TSS is with something designed for TSS. And usually they'll send a sample, and again, many of you may have experience with this, to a lab, they'll dry it out and they'll actually weigh the particulate in that sample for TSS. Turbidity meters quantify light scatter at 90%. So you can see in my little diagram here, this is a view from above of the system. You can see the light source going through the lens to the sample chamber. And then up top here, I don't know how to use these pointers. Oh, nice. So that's where the sensor is actually located at 90 degrees. So with all turbidity meters that meet these EPA requirements are checking light scatter at that 90 degrees. So that's where the actual sensor is. It just helps a lot to have a visual on this because it can be a little hard to picture it without that. So there are two main methods that affect our industry. There are many more methods for industries like wastewater, where turbidity's upwards of 20,000 NTUs. They may use different technologies, but for the most part, for environmental monitoring purposes, we do EPA method 180.1, which uses a white light source, usually just a standard tungsten type lamp is installed in these, and the ISO 7027, which uses an infrared, usually an LED light source. So to the best of my knowledge, every standard turbidity meter that's available out there on the market, including ours, has both of those options available. So make sure you know what method you're doing because you want to select the correct approved lamp for that particular method. So now that I've talked about the methodology, I just wanted to talk a little bit about the Geotech turbidity meter. We designed this to be very robust for the field. We've considered some frustrations that people may have with field equipment. For example, shockproof, waterproof, it floats in water. The sample chamber itself is watertight in the sense that liquids aren't going to work their way through down into the electronics of that unit, right? We're dealing with water here. So making sure that it's a fairly well-sealed system is important. Multiple calibration modes, you can data log up to 1,000 data sets. One button, read, save, very intuitive to use. And again, it's available with both the lamp styles that I just described. Standard items, of course, case, sample vials, primary cal standards, and here in a moment I'll talk about primary versus secondary cal standards. Lid-free cleaning cloths, which should always be kept in that case and out with your unit, and batteries, so you're just ready to hit the ground running when your turbidity meter comes in. Optional items include a field style case, the USB download cable, which I recommend getting, minimum upfront investment, and secondary cal solutions. So now that I've talked a little bit about our instrument, just wanted to give some tips for success in the field. Many of these are general. I know Nobody out here, either in the virtual land or in this room, has ever forgotten to bring spare batteries out to the field, so I'm sure I don't have to say it, but bring spare batteries with you. Small Phillips to replace the battery cover. Bring your lid-free cleaning cloths and bring your Cal standards, either primary if that's all you got or secondary. You always want to handle turbidity standards turbidity calibration standards or sample vials by the cap. Remember, we're dealing with light refraction here, right? So greasy fingerprints and lint and dust, anything like that's going to have a significant impact on your reading. And the instrument may not know what's going on, and it may see that as a highly turbid environment or some other strange conditions. So be really cautious with how you handle that. Glass isn't perfect, so when they index the sample in calibration bottles, they index it so that glass is going to have the least amount of influence on your readings at both the point where the light is going through the lens and at that 90-degree angle where the bounce back is being scattered. So make sure you align the bottle properly. There's a little diagram. It's very easy to do, but it's an important step. Best practice. I mean, field notes, handwriting, just hit that save button. Even if you don't have the USB cable, you can always buy the USB cable later if you're like, oh, I'm really not sure. You want to make sure you have more defendable data. Just hit the save button. It'll store that reading for you. It takes 1 second and you'll be set to go. And then finally, obviously, wipe the bottles off using that lint-free cloth. If you don't use the lint-free cloth, you're likely to introduce more issues than you're going to get rid of. Cool. So last couple minutes here, talk a little bit about maintenance. Anything with alkaline batteries, take them out when you're storing an instrument for longer term use. There's good checks that there's good practices to use just with equipment management in general. If equipment's not going to be used for a period of time, just systematically going through all the equipment, pulling the batteries, making sure that covers are closed, that type of a thing. Make sure that you dry out the inside of the sample chamber. You will probably introduce some moisture to that. That moisture is going to dry, and that can impact your readings down the road, right? Calibration standards, in particular, formazine standards, they're not durable. Don't ship them overnight if it's snowing outside. Don't put them in the back of your truck with the sunlight beaming down on them. It's best to avoid doing that, and ideally invest in the gel standards as a backup. Take those with you to the field. Do your primary calibration with a primary cal standard, which is required, and then leave your formazine standards in the office. Take gel out there as a confirmation to make sure that everything's working okay. Again, obviously, keep bottles and lenses lint-free. Keep the cover on the unit closed. Keep the unit in a case. And will scratch over time. They need to be replaced. So inspect them at the beginning of the season and make sure they're in good shape before you move forward. So that's all I had for you. Just to review, the turbidity is a measurement of water clarity that can affect aquatic life and drinking water. Nephelometry technology works by shining a light sample and detecting the amount of light that's scattered. Method 7027 uses white, ISO 180.1 uses white, ISO 7027 uses infrared. Our meters are robust and user-friendly, so contact your Geotech rep if you want to pick one up. And as always, proper field preparation and equipment maintenance is key to being successful. What kind of questions do you have for me?
Nothing on the chat.
Awesome.
So here.
I answered everything for everybody in this presentation. I'm that good. I'm running like 5 minutes at a time, so.
Oh, we got one over there.
All right, hopefully I can answer it now. There's a big build up to this.
I was just wondering why most field meters cap out at 1,000 NTUs, and do any go above that?
I'm not sure if other competing meters go beyond that. We really don't see, the requirements are pretty low for what we're seeing. So again, EPA methodology is going to say 280 max. So, 1,000 gives you a pretty large range there. Other field meters may read higher, definitely other technologies. For example, prior to this, they were talking about wastewater technologies where you see really high NTUs. So I know the technology exists, but I just don't think we see the numbers very often in our industry.
Okay. Yeah, I just use it for well development and trying to track that it's increasing, and if it's over 1,000, it's over 1,000. So.
Yeah. I would be happy to look into it though for you as well. So if you want to drop me your card, I'll see if I can learn some more. Maybe there's a market out there too that's untapped for exactly things like that. How quickly is this well developing, or et cetera.
Thanks.
Yeah.
As far as internal cleaning goes, vials, just alkanox, or is there anything to avoid the residues or anything like that?
Alkanox I think would be fine. I think the consideration I'd have is more making sure that everything's dried properly. Yeah, and make sure that you're not smudging anything. So just using that lint-free cloth and just making sure that you get any water droplets that are sitting at the bottom, would be fine. But just a normal low phosphate-free cleaner should be fine.
I never thought about this, but I've rented the flow-through cell, do groundwater sampling, and one of the parameters we detect is turbidity. And I've never seen a lint-free cloth come along with that. So can you use just like a glasses cleaning cloth, or is it a specialty? Because I've never tried to clean the turbidity probe.
You
In the
probably
flow-through cell.
just gonna want to use water. On
Just
those
as long as
units.
it's still,
Yeah. I don't think you would want to use a cloth on a song, if that makes sense. They do have meters that have a wiper that will go around and clean the optical sensor on them. So I think that would be a good application for that.
But thank you. I'm honestly unsure. Any other questions? Cool. Thank you, everyone. Thanks, everyone virtually. Thanks, everyone that's here. Appreciate it.
Thanks, Amy.
Thank you.
Thank you.
All right, everyone, up next is Chris Howard with Is Turbidity.
Awesome.
Let's test it. Awesome. Cool. Thanks, Chris.
All right. Do I stay right in front of the podium here so everyone sees me?
You don't have to.
Okay. Good. No one wants to look at me anyway. All right. All right. I'm Chris Howard. I am the regional sales manager for the Mountain region for In Situ. And my topic today is going to be water quality instrumentation. Those of you that In Situ, we do more than water quality. As you see on the slide, we cover a multitude of different items, and if any of these resonate with you guys, shoot me an email. Better yet, give me a call. I'd be happy to come by your location, your state. Now that everything is opening up, it's great to get out again, get out of the house. And if I don't cover your state, just shoot me an email as well, and I will get you with your local RSM, and they will be happy to come by and see you as well. All right. For multi-parameter quality sondes, we've got 3 different sondes that we sell. We've got the AT400. Now the AT400 basically comes with your standard set of sensors. It's going to be your type of conductivity, your pH, RP, your turbidity, and your RDO sensor. Now on the 400, these are not changeable. Basically, the unit is what it is. So you can't take sensors off, you can't replace them with a different sensor. If you want to go out, say do a blue-green algae test, you can't pop a sensor off and put one of those on there.
Now the AquaTrol 5 and 600. I have more of a show and tell guide than a slide guide. These are our 500 and our 600 saws. Now the only difference you can see right here is that the 600 is a little bit longer. And the reason being is that it has its own power source. Just regular D-cell batteries. This is for more of a longer term deployment. And if you're not going to be doing like hooking into another power source or a telemetry system, this is the unit that you're going to want to do if you want to do anything longer than a day, essentially. The AT500, again, is basically the same unit. And the same sensors actually fit on the 500 and the 600 unit. So if you have a 500 and you want to take a sensor and put it on your 600, all of our sensors have computer chips inside of them, so they will transfer over already calibrated. You can see that they are all smooth all the way around, so you're not going to get any anti-fouling in between any of your sensors. And our sensor tops are all flat. So with our wiper system, we're not only cleaning the top of this, but we're also cleaning the top of your restrictor.
Chris, you want to show that to the camera real quick?
Yeah,
Sorry about that.
that's good. So when we built our sondes, we basically went out and we asked all of you guys, what are you seeing out there? What needs to work better? And these are basically our common issues that we got. You know, they're complicated to set up, they're expensive to maintain, they're not accurate, and they're not reliable. So how we went about fixing that is that we made it to where everything is built into your sonde for ease of use. So, for instance, Calibration Cup. Right now, this would be in deploy mode, right? We got our holes here, water's flowing over your sensors. So to move into the Calibration Cup mode, I'm going to spin off the end of the cap here. Right. We're going to slide it on with the holes down. And this is now your calibration cup. So only 50 milliliters of calibration fluid will fit into this cup. Most of our competitors, you're looking at about 250 milliliters. So just for cost savings that we usually predict is about, depending on how much calibration you're doing, how many sensors you have on the sonde, you're looking at about $1,500 to $1,800 a year in calibration savings. So our shared ecosystem. So right now, our twist lock cable connector. So again, the AT500, if you deployed the AT500, you would need a power source since there's not a battery. And you would plug it into our twist lock cable connector. Now our twist lock cable connector will fit on all of our items. So if you go doing, say, there's doing level, and you have a level troll 500 out, and you want to go deploy your AquaTrol 5 or 600, well, you can use the same cable because all of our cables work on all of our gear. So I don't remember, you guys remember the old cell phone days? You'd go in, you buy a cell phone, and then you have to go back in, buy another cell phone, and they'd sell you another charger, and you have to pay an extra 35 bucks. It always drove me crazy. So I love that we have one cable that fits all of our gear. And to go with that, the wireless tool also Bluetooth to all of our gear as well. So I don't know how many different handhelds you guys have for how many different instruments that you have in your shop, but all of ours read off the same wireless tool comm. already covered the Calibration Cup. So multi-depth deployment. So we got this little fun guy, our rugged splitter cable. And this will allow you, say, so Modbus will do 4,000 feet of communication. So right now I just deployed one of these for a cluster well. And basically what you're going to do is you're just going to hook up your device up top. So say it's the view link, or you save it to put your wireless TrolCom up top. And then you're going to connect another cable down, put your level troll on, have a level troll here, and you can just keep adding splitters. So say you have a 3,000 foot well, and you want to get different characteristics of level at different spots in that well, you can just keep going and daisy chaining off of the splitter and drop everything at different depths, right? So it's going to save you guys from having 6 cables going down to do that, and it's going to save you a lot of space inside your well as well. All right, the anti-fouling. So this is actually a picture, obviously, that we took out of a site. It's pretty nasty looking. Another picture of it. So what we really want to look at here is the wiper right here on how it's keeping everything clean. So what's great about our wipers too, like I said, it's not only doing the top of the sensor faces, it's also bi-directional. So I usually sit in my office, I call him Alfred for some reason, the wiper, and I sit in my office sometimes and I'm just kind of spinning this because I'm looking at my computer and my wife will yell at me, stop playing with Alfred. And so most wipers will spin one way, right? And they get stuck and they're going like this, they're clicking. And all of a sudden you guys are getting this, the reading when you go back out there that the wiper motor's gone bad and you have to buy a new wiper motor. Well, ours, it'll keep spinning and it's going to hit something and then it's just going to spin the other direction. And eventually it's going to clear out whatever the obstacle is on the sensor. Don't try that with your device, because if you break it, I don't want you emailing me about it. So. All right, rugged cables. Not gonna lie to you, our cables are not the cheapest cables in the industry, but there is a reason that they are. What they are is that we do put a Kevlar piece of metal down inside of our cables to prevent drift. Now, if you're looking at a 10-foot cable, yeah, it's probably not going to make that big of a deal. But if we're talking about a 1,500-foot cable or a 750-foot cable, and you guys have to keep going back out again to reset your well, $40 more that you're going to pay for one of our cables, more than you're going to pay for the cost of sending somebody out to reset your well. The other thing about our cables is that we make everything to the foot. So if you guys need anything up to 4,000 feet, you need it 3,971 feet, that's the cable that's going to show up on site. So you're not going to have to stuff extra cable into your well casings. We do have 2 different types of cable. We have a poly cable, and then we have our test cell cable. And that test cell cable has this plastic coating over the top of it. And that plastic coating is almost like a Cat 5 cable at your house with that sheathing on it. That's really for your remediation sites. Water's pretty nasty, and you want to be able to clean up. So we have pH sensors, they have pH sensors, they got turbidity, they got BGA, so do we. So what's really the big difference on us versus the other guys? Usage. So How many of you, we'll make this a non-participation one, make it easy. How many of you did not bring a cell phone with you today? Right, you would get about a mile from your house, probably have an anxiety attack that you left your cell phone at home, turn around, go back, and pick it up, right? So everyone has the ability to download our gear with a cell phone and a wireless control. All right, so what was the software? What are all the software issues everyone's always talks about? Licensing, upkeep, complicated. The licenses are expensive. They're not reliable. Well, our app is free. It's in the Android and the Apple store. And also, if you guys, want the bigger screen, just buy a pad. I mean, I could sell you one, but you can go out and buy one if you guys have one that is Windows 10 or does Bluetooth. You can also connect. Okay. And again, it's free, so it doesn't matter how many people you guys want to use it. Just download it and come by the booth. I'll show you how it works. It's great. Basically, wireless Trocom and shows battery level. You're going to get about 40 hours of battery life out of these. So I always kind of recommend bringing a second one with you. And all of your firmware updates. So when you download our update of our app onto your phone or your tablet or your computer, you guys go out and hook into our gear. It's going to let you know, hey, we got some updates to do. So depending on how big the update is, how many updates that you might have skipped, will depend on how long it takes for you guys out in the field to do this update. But it is usually pretty painless and pretty quick. Live data. So not only can you do all of our logging, set up your logging on here, but if you're doing low flow, you guys can get live data. And right here, you see this little mark, oops, this little mark button right here. You guys are out there and you're looking at live data, and you say, hey, that kind of looks a little funky. You hit that mark button, and when you guys a report, it's going to be a yellow line through your report. For calibration, walk through calibration on the app. So I did a presentation at Red Rocks High School, local high school here in Colorado, and there was a bunch of new students there that were thinking about getting into the water industry. And the professor came down and would do a class once a month, and he goes, "Hey, will you come by and show them your gear?" So I'm like, "Yeah, sure. It sounds fun." And we went by, and one of the students downloaded the app, and we said, "Okay, well, I want you to calibrate this unit." He goes, "Well, I've never done this before." I go, "That's fine." So he just went through step by step and calibrated the unit. You've never even seen a SON before. It's super intuitive. It's super easy. Log setup. So when you're setting up your level, again, this is kind of like the calibration. It's going to be going through step by step. It's going to ask you what type of logging you want to do, set your reference. So for instance, on this one over here, we've got, right up here, a lot of people always do the depth of the water. You're going to set your reference points, on your log, depending on what kind of testing you guys are doing, on what linear average logging you're going to want to do. And it, again, is very intuitive and easy to do. Unlike the button.
I think it's more towards the card.
That's good. I think it's a little pointer over here. There we go. All right, simple data management. So how many of you guys are still writing in a book? All right. So you guys take a 6-hour plane ride. and you take a 4-hour car drive to the mountain, hike 4 miles into the woods, meet the Sherpa. He takes you up another 4 hours. You guys do your testing, and you get back and no book. Now, you can say, well, I've never lost a book. Awesome. So I just flew, I don't remember where it was, but took a plane ride, and the airlines decided that I did not need my gear. Right? And, I don't want to, say out names on airlines or anything, but it rhymes with United. And so I'm there, and I have no gear, right? So you guys never lose your book. But what happens if you check your bag and you get back after this plane ride and all this travel and the client's expecting information back and your bag's in Cleveland, right? So right now with us in using the app, you just email it to yourself when you're done. The report just comes in Excel format. It's super simple, no transcription errors, right? I don't know about your guys' writing, but I mean, if I was writing a bunch of numbers, I'd be like, is that a 2 or an 8? My handwriting's awful. But right now, you can email us to anybody. You guys can modify your recording. You guys can take all that data and use it however you want to. But the ability of just being able to have it at your fingertips and send it out and not having to worry about if your data is lost, if it's good, if it's accurate. Our app does it all for you guys. And you guys can API our gear into different formats. If you guys have a specific format that you guys like to work in, you guys got a program at your company, you just pull that data in, and it's very simple. We actually have a kind of a step 2 guide on our website on how to do that. So I'm trying to squeeze in about an hour here into 20 minutes. So trying to hit some of the big points. So on our groundwater sampling, another fun one is that the AT, again, the AT600 does have a battery in it. So you can just put it into our low flow kit and Bluetooth to that unit. If you go with the AT500 unit and use the Bluetooth unit, instead of standing out in the 34-degree sleet, you can be inside your truck or your vehicle, Bluetooth to the unit, and it will let you know when it stabilizes. So when it's all green, all stable, you're nice and dry, sitting in the vehicle drinking coffee, the low flow is going, and you hop out and you finish up the test. And again, this is kind of the parsing guide I was just talking about. So, and that mark button that I was showing you with the yellow. So if you hit mark on your test, and you get your report, that's exactly what it's going to look like right there, right? It's just going to say, hey, I saw something funky, and I want to review it later.
I think we're going to open it up to questions. Let me check the chat. If there's any interesting ones, we'll start with those.
How hard is it to change the electrodes in the bigger units?
The electrodes?
Are the SON readers?
The sensors?
Yes.
Yeah, actually, I'll show you. So, this little Allen key that comes in the kit, and all the little screws right here. What's great is all of our screws on the back have a spring on it. So you're out in the field and you're cold, your hands are cold. Up top, they're all wet mitt connectors. So if you've got some mist, obviously we don't want you pouring a gallon of water down the hole. But if it's out in the rain and they get little bit of rain on them, you don't have to worry about it, you can set those in there. But again, that screw's not gonna go anywhere. You just take it, pop it back in, and tighten it up. Also with our sensors, none of them are port sensitive, so you don't have to have, the temp conductivity sensor in port 3. Or I could take all these off, mix match them up, and put them anywhere I wanted to.
If you have one of these installed in a well, how often would you need to recalibrate it?
Depends on what sensors you have in it. The pH one on our standard set is the one that you're going to probably be doing the most. But it really depends on obviously the water quality, pH levels in it. We do have a refillable junction on our pH, so it's not one and done anymore. You guys can, if you guys are taking care of your sensors, you should get it at least a good 2-3 years out of most of them. Anybody else? Yes.
I apologize, I missed the very beginning, but how are these deployed in a portable sense if you're bringing it from well to well around the site?
Sure. So if you're going to be doing, that's what I kind of call like day sampling, where you're just kind of dropping it in. So you use your AT500, and then again, just have a cable connected to your wireless TrolComm, and then you're just tapped to your wireless TrolComm, and you're dropping it down, and you can just create a new log for each different well.
So just go on top of the pump then, if there was a.
So we need a 2-inch well for this. So depending on how much pumping line you have in there, obviously, hopefully there's enough room. We do have, sometimes people are just looking for conductivity. So we do have a sub 1-inch for that scenario if you're just looking for temp conductivity. But if you're looking for other parameters, you can slide by. Another thing with that TEF cells, that blue cable I was kind of talking about with that coating, like your computer cable. If you guys have a ton of lines sticking down into a well, that poly cable is a little grippy, right? So it's going to go down the well. You're going to be hitting all your pumping lines. You can kind of snag out. But if you get with that blue casing one, it's slick, right? Just like a computer one, and it's able to get by those other pumping cables a little easier. So something to kind of keep in mind. Anybody else? For those of you on the webcam that can't see, there's about 1,000 people here, but they're just really shy.
Awesome, I think that wraps up questions. Thanks, Chris.
Thank you.
All right, we're going to get started here in about 30 seconds. Just hit us with any questions, and the moderator on the chat will let me know if you have any questions. If you're not hearing me or if you're having audio problems, please go ahead online and say so on chat, and we can make adjustments, which is odd that I'm saying this verbally and asking you to do that. So if you hear me, then clearly not an issue. Okay, awesome. So it's 11 o'clock. We're going to get started on the SitePro telemetry system. And first of all, I'm Jason. I work for Geotech Environmental. I'm one of our sales managers here. I've worked with Geotech for 20 years. This product is something I'm really excited about because I've been working with surface water and remote data collection for a good 10 years now. And it's something that I think it's a product that really complements what Geotech does here. We work with a lot of different companies, a lot of different suppliers, and we wanted something that was going to be truly honor those kinds of relationships that we manufacture here, also provide something that's really valuable to our customers. So I'm going to get started, and we'll just keep going. All right, so for some reason, the slide is not advancing, so let me try it here. Okay, so first of all, we're going to go over a little bit of an outline here. So history, why time series data? That's what data collection and telemetry really provides for us, is time series data. That's the goal, that's what we want from it. We're gonna go to the technology, inputs, and some sensor examples, and some applications. And we got some real life examples that just happened literally in the past year with this product line. And it's really cool to see how this developed for us. So let's start with the two types of data collection. First of all, let's look at spot sample data. What I mean by spot sample data, that's when we can go out and take readings manually, in person, with equipment live, right? So we're going out there, we're walking out there, we're getting the sample water, or we're taking a monitoring device, putting in a stream, river, a tank, or whatever, and we're having to be there in person to do that. It's labor intensive to do that, right? We have to have personnel trained, certified in many cases to be on site to do that. It's also, we can only do it when the time is right. Say it's too dangerous to be out there, right? It's maybe weather conditions do not permit, site conditions do not permit, maybe we don't have clearance on the site all the time to get out on the site to collect the data. So there's a lot of different reasons why, you know, we can't get on site, so we can only get it out there when the time is right for a human being to be out there. And in certain cases, maybe, you know, we don't want to collect data at 2, 3 o'clock in the morning, right? So there's times of day where it's just not optimal for a human being or a person to be out there to actually collect that data. And also, the data is limited to the spot monitoring time. We're only getting the data when it's optimal for us to be out there, and that's only going to represent when we can be out there, right? It's not going to represent data or what's happening on site when we are not there. And of course, things can happen when we're not there that we want to monitor for, and it could actually change a lot of things for us. So doing remote data collection and doing telemetry is key to changing that. And here's what we mean by that. We're calling, when you're doing remote data collection, you're doing unattended monitoring. That's when you're not there. That's when there's no one in attendance to do the monitoring. So equipment has to be designed to remain on site. That's a key requirement. We have to have equipment that can actually live on site and be durable enough or be rugged enough or have sensors or technology that can actually live out there full time. And some technology does not lend itself to that. We collect readings at regular intervals or triggered. So we actually have the equipment that can actually record the data at regular intervals, or per a sensor trigger, actually jump in and say, hey, this changed, it's time to start monitoring, right? And we see that a lot of times with like stormwater monitoring and stuff like that, where we see a trigger and that's when we want to monitor. That's the event we want to capture. And stormwater is a great example of that. Provides a lot of data, but it's also time series data. So a lot of people are like, oh, I'm going to get a lot of data points. Yes, but those data points are time series data. We get to see trend over time. And that's really powerful data compared to spot monitoring. Spot monitoring is great, but unattended data gets you, hey, what happened at 2 a.m. when a rainstorm came through on this river or this storm sewer or on this job site, right? So what's happening there? What's changing, what's happening over time? It can also lend itself to remedial processes. Maybe we're doing remediation processes on site and we need to see what's happening on the outer wells on, say, a groundwater application where people are injecting chemicals and we have to keep watching it. And it's inconvenient for people to be out there 24/7 to do the monitoring. So unattended data, really, it lends itself to getting us that data and that we really need to make powerful decisions. It's a better holistic picture of the site. Once again, we're seeing what happens over time when we're not around, when we're on vacation, when it's a holiday. We're getting data then too, right? It's also it can be safer. Take an example, if we're monitoring tailings ponds at a mining site, right? Would it be safer to have a fixed monitor out there bringing in data, or someone going out there repeatedly climbing into that pit to take that data? What's safer, right? Alarms for events, i.e. flooding. Having sensors out there and out in the field, and say you put them on a river and you have a water level sensor, and we're worried about flooding events, we can have a system set up that is triggered by the flooding event, starts recording data, and sends an alarm saying, this is coming down the valley, right? So having this powerful data, this unattended monitoring and telemetry really lends itself to a greater use. So that lends itself to the technology, right? What is a SitePro telemetry system? It's a storage telemetry system. If we're going to actually log data to it and be able to recover that data and view it online. We're going to also go over some SitePro models and do some examples on these SitePro models, right? And how we've used them. We're going to give you some examples of sensors along with the install examples. And this is what we want you to understand is SitePro is not just the box. It's what we can, where we can put it, where we can use it, and where we can fit it. So what's in the telemetry system? Currently, the way it's designed, internal data storage of 32 gigabytes. Now, if we're doing data collection, this is a huge amount of data. It may not seem large for an iPhone, right, or a cell phone, but it's large in data collection because we're just doing data points. This is a huge amount of data, that we can access. It has a radio. The main radio that we use and we use most commonly is an LTE band radio. That means we're using cell phones, towers to get our data to the internet. But there are other options out there. You can use just a radio-to-radio repeater until we can get it to another box to get it to the internet, or we can use GOES. We can use a lot of different radio platforms out there, but the one we use 9 times out of 10 because cell phones have reached so many places is we can actually use that LTE band. And that's the new band. There's a lot of older systems out there that are running 3G. Those are actually getting dead-ended by the cell phone companies. So if there's people out there that are using data collection systems right now that are on 3G, be forewarned, those days are numbered. So you might want to start looking at LTE-based systems soon. SitePro model options. Right now, just in a standard box configuration that we're doing, keep in mind, that's just what I've been saying, is just standard, and I'll show you some custom applications though as well. We have a single battery and dual battery option, a single solar panel and dual solar panel option. We also have AC power. So if you have power on site already, might be pretty just reliable and efficient just to go with a line power. We're still going to have a battery inside to run the system and power goes out. But single and dual battery systems, we start looking at how much equipment we're hooking up to the data logger and telemetry system. Depending on how much power the systems require, how often we're taking readings, and like I said, how many sensors we put on there, we might go from a single system to a dual system or more. So we sit down with the customer and we sit down and go over the site objectives and what we're planning to put on there, and then we can figure out which system is going to work best for them. We can actually set it up with or without display. So you can actually have a display on the unit so you can walk out there and get a current reading off of it. Now keep in mind, that's great to have, but when I show you the website and the data backend, the site view here on the next presentation, realize that you may not need that, you may want that. It depends on if you just want to use your cell phone to collect the data right in front of the box, because you'll be able to view it there as well. We have custom builds, and like I said, those are the standard options, but we've done some custom builds where we've built complete panels with the SitePro in it with a bubbler system. That's a type of system that's used to detect water level, right? And in sites where it freezes, bubblers become a great option because you don't want to freeze the pressure transducer. So we've built special custom panels that have the bubblers built in with the SitePro. We've actually built the SitePro into a buoy system. And so we have the ability to add water quality buoys out to lakes, reservoirs, tailings ponds, you name it, and collect data from those as well. And we can also just add to an existing panel. If someone has a pre-existing SCADA system in there, and they just want to pull the data off that SCADA system, telemeter, we can build a system that would integrate as well. So there's custom options that we can actually build with them. So I'm going to go, so examples of sensors. We can go as simple as just a water level and pressure sensor. Just monitor water level on site. I can't tell you how many times this is the most common application we see, actually, for lakes, rivers, And groundwater. People want to monitor what's happening with water level more often than not. That's a very common application. But if, say, the site is 4 hours away and you have a whole bunch of wells that you need to monitor and you need to do it frequently, that could be pretty inconvenient. Adding these systems out there and getting the data in and watching that consistently will give you that time series data without all the travel and drive. We do single parameter water quality sensors. So we have like a brand here that we offer called Aqualava. They actually are a single parameter system that ties into our box. You can just do a pH sensor. You can just do a turbidity sensor. You can just do a conductivity sensor. It depends on the application for the site. You don't have to go full multi-parameter suite to actually get those readings. But at the same time, we also work well with multi-parameter water quality sensors out there. We have 2 vendors here today that do very well on that. That's In Situ and YSI. They both offer multi-parameter sensors that will tie into our system. We also deal with meteorological events. We can do rain sensors. We can add weather stations like the Trisonica that do wind speed, direction, barometer, temperature. We can do water flow, open channel pipe. So we have done projects for irrigation districts so they can monitor their water levels and flows and actually monitor that tightly so they know what's going on for their users. That's another big market, is just the irrigation market out here in the West, right? We actually have to measure and monitor our water very accurately and consistently on what we're delivering. That makes all the difference in the world to the farmers out there. And also anything we can talk with. The key thing I want to bring to you today on the SitePro is it's a sensor agnostic system. As long as we have, it has the sensor communications that we can work with and we can talk to it and get data off of it, we can provide you that data. So you're not, and that's one of our driving forces with this system is we didn't want people to be married to just one brand of technology and one brand of telemetry system, which would be limiting for them. We want them to be able to use what they feel is going to work best on site, as long as we can work with it as well and talk to it. Which brings up another thing, is some install examples. All right? So on this one, and I'm hoping the video is going to work on this because this is a fun one. This is a site we did last year. The customer had an issue with a reservoir. It's a HABs issue, that's harmful algal blooms. It's also a publicity issue because this reservoir happens to be in the middle of a city. People fish on it. People have biking paths going past it. And when they have to put the caution tape around the reservoir and tell people they can't fish there, they can't play with the water, they can't touch the water, that's a public relations issue in addition to the treatment issue for the water treatment plant. So the water treatment plants having to maybe shut off their intakes and not take that water. Or they're having to use a lot of chemicals to treat that water, which creates taste and odor issues, and i.e. you get more complaints. So they wanted to measure parameters of concern on this reservoir. Those parameters were algae, so total algae, chlorophyll. They also wanted to monitor turbidity. And also they had a device on site called a solar beam. And if you look at the picture down on the bottom, on the right there, you can barely see it out there. It's a tri-floated platform with a pumping system in the middle that circulates water in the reservoir. They're very common out here in the West with a lot of smaller lakes and reservoirs, and some larger ones where they're having some, like, panhandle issues where they have like little reaches where the water doesn't mix as well. So it mixes the water, keeps the water from stratifying during the summer and creating bigger issues with algae. So, but they also were adding an oxygenation system, a bubbler system to this reservoir too. They wanted to be able to monitor that. So dissolved oxygen was really key for them. They wanted to see what was happening with the dissolved oxygen. They didn't want the fish kill. And when I was on doing a site visit, they actually had fish delivered. So that was one of those situations where here they are getting, some stock for the people that like the fish on the reservoir, but they can't have the fish die either. So we've got to really monitor this site. So I'm going to go ahead and try and see if we can get this to activate and work here. This actually is, and I'm going to have to go back in here and reshare my screen. working on it, sorry. Let's see here. Just need to scroll down. And see if we can get that to work again. Sorry for the delay. Just trying to figure this out. If I can't get it started here in another 30 seconds, then we'll have to pass it by. But all right, so let's see if I can minimize. Can't minimize that screen for some reason. I'm getting some tech support here, folks. We may not be able to show this, but I'm going to give it one more try here, and then we'll just move on. Let's take a look here. Yeah, I don't know if people on the other side are being able to see that right now, so I'm just going to go back to the presentation. I apologize. But if you want to link to this, basically it covers Colorado Springs utilities actually using that as a monitoring device down there on the solar bee. And it was really neat to see the news come out and really champion the site. And I'm going to go ahead and reshare the PowerPoint here for people online. Okay, we're back to the red box. So apologize, I was hoping we could make this more dimensional, as it were. But I do have this link. Colorado Springs Utilities installed the system. It was really cool to have them just be on the news, say, hey, we started it up, it just worked, right? Now they're collecting data, they're making a lot of more powerful decisions. It took the lab years to be able to get approval for this, but it's really cool that we were able to develop a system that would work with the solar bee and just get data for them. So there we have that. Okay. So another application, we have a customer here locally, a landfill. Landfills collect water. They're big basins for it, right? Leachate and stormwater needs to be collected coming off the site. Well, on this application, we detected the water level. We fill a tank. The tank gets to a certain level, it gets pumped to the treatment system. So not only is the SitePro telemetry system there to collect the data on what's happening there, but it also can be used to actually turn pumps on and off and actually provide some control on site. So that's another application. And I don't have a picture for that, but we're going to look at some data when we get into the site view demonstration after this presentation. Another really cool one that we did last year, this is for Lower Arkansas Valley. If you're familiar with the Lower Arkansas Valley, it's a big agricultural area for Colorado. And a lot of farmers are using irrigated water down there. But there's one big issue from the irrigated water. They have a selenium issue with the river. What happens is the farmers water with the river water, and they comes back and drains back towards the river. Due to geological formations below where the farmers are farming, it's picking up selenium and bringing it back to the river. So every time a farmer waters, he's bringing selenium, adding water to his field, it drains back and gets selenium. Then the next farmer downriver picks it up and does that again. And the next one downriver picks it up again. And it starts building up selenium as you go farther down the river. Well, they used many approaches to start resolving this issue and look into this. And one of them being an ag station, an agricultural station. So what we did on there is they're monitoring meteorological data, wind speed, direction, temperature, barometer. They get an idea of what's happening with the weather. How dry is it going to be out there based off that, right? We can actually calculate that. Then we did soil moisture. What's happening with the soil when we water? So we have soil moisture probes out there actually profiling what's happening with the soil moisture for the crops. And then there's a rain gauge. So when we're getting rain, we can measure that. Or they can actually use the rain gauge to measure their center pivots if they're using center pivots to actually water the system, right? Using this system, they were able to optimize their water use and study different irrigation methods and optimize those irrigation methods and reduce the selenium buildup. This is changing the water quality for the river, right? Because we're not overwatering and we can optimize how much water we're getting so we're not really pulling the selenium as much as possible, or not as possible, as little as possible from the formation. And so, yeah, overall net benefit, reduced discharge of selenium to the river basin. So we're at the point where we can do a quick break and after some questions. Any questions on the SitePro telemetry system? Yes.
Can you, if it's connected to an existing SCADA system, bring up that view and mess with the system from far away, turn pumps on and off, or is it more of a set it and monitor and not?
I'm going to say yes, just because it depends on the system though, right? So what our salespeople and engineers would do is sit down and just get as much information as we can about tying into your existing SCADA system and how we would collect data from it, what its sensor outputs and inputs are. One thing I didn't have, there was a slide for it, and let's see here. So our sensor inputs, we can do 4 to 20, SDI 12, pulse, Modbus. We can take a lot of different sensor inputs. So that being said, and that's changing every day on what we can take in. We used to have a limited number of 4 to 20 milliamp inputs. That's growing. So we're adding, as needs come up from customers, we are adding those applications or those, modifications to the panel itself. So keep in mind, it's not just, we have some boilerplate models where you can just buy the box and have a pressure sensor on it. And there's some custom engineered applications that we can do and consult you on. Any other questions?
Does it have a built-in data logger?
Yes, that's the 32 gigabyte recorder. So on a lot of devices, if you look at the multi-parameter songs, they have their built-in loggers, but that has to be accessed via a computer, right, to pull that data off of. And it's always good if you're running a multi-parameter device out there and it has its own built-in logger, run it anyways. Use that as a backup, right? But we have the recorder on our unit as well. So you have two areas now where you can keep that data. And what's nice about this, say we lose signal for a little while, a trucker hits a tower, right? Or something happens to a tower. You're still recording data, so when the cell signal comes back, you can actually grab that data again, right? And we'll show what that kind of looks like with SiteView, because there's a way you can actually check in and see if it's online, offline, stuff like that. Okay? So yeah, you got your data backup built into it. Any other questions?
Nothing on the chat.
Nothing on the chat? Okay. We seem to be doing good on chat. How many people do we have on chat?
9.
9. Okay, good. So I'm going to assume all of our questions have been answered on that. So when I'm going to see if I can just maybe in the last few minutes here get this video up on the screen. I don't know why it's not popping up on the screen though.
Yeah, the one thing. Do you know how to get to all the windows?
Yeah, I can stop that. I think that just probably wants to present that. Okay. Now let's go back. I think that this is that might be an issue. How this one's going. Yeah, but I have that on every side code. No, I know. Here you go. All right. And let's see here.
Now we'll see if it even, well, yeah, the videos somehow get blocked by Google, so. Extra technical issues that I just can't overcome today. All right.
Worked great yesterday. All right. So let's bring that PowerPoint back up. And then we'll get started on site view here in just a second. And this is where you guys can actually see the data from some sites and how the actual site view data works. Okay, so I'm going to jump ahead. Okay, so we're just going to go ahead and get started on site view and what is site view and how to use site view. So site view, when we're using the Site Pro panel, is our true portal for collecting our data and viewing our data from the Site Pro systems. This is a software as a service. So when you pay for your yearly fee for this, you're not only just paying for the radio for the year, which is the LTE band radio or what we're using, and you're also getting your website. So this is the hosting, and it's a great system. We've added a lot of functionality to it this year, and we're constantly adding functionality to it. For some reason, PowerPoint is jumping around. I don't think we're showing this correctly, so let me try this again. There we go. Okay, so people online should be able to see this. So what is site view and how to use site view? Site view is where you go to get your data off the Site Pro telemetry system. It's stored there, it's online, it's easy to access. This is software as a service, as I said. A lot of people call it just SaaS. So that means you're just paying a yearly fee to have this software as a service provided to you, which is nice. It's not living on your computer. It's actually, you're accessing it through a web browser, which means if you have a mobile device with a web browser and it's got connection, you can actually pull your data up. Once again, you can actually be on job site and you don't have to touch the box, you don't have to touch the sensor, and you can still pull it up and look at your data. So it's available on computer or mobile. It allows different user access. So different user access, admin can make changes, set up users, download data. The guest can log in and view the data and download the data. And API forwarding is something we can actually do on that as well. So what that means is if you already have a data collection system and a software for your company, so your company already has a large data system that you're pulling data into, we can actually use SiteView to link to that and push it to that site. So we just work with our software engineers and your IT department and build that link. So you can log in, view data, download data. Data is downloaded in CSV format, so you can just get it in an Excel spreadsheet, really easy. It's a less restrictive format. There's no software to download unless you don't have a web browser. That's why my MS Edge exists on most PCs, so you can download a web browser. I joke. You know, I got this little Rick and Morty, what is my purpose? You install Chrome. Right, Microsoft's Edge job is just to install another web browser. No USB transfer, so you don't. There's some stress in there. Some sites, such as Federal, are locked down from using USBs. They're just not allowed to use them. Can't touch them. Don't even bring them on site. They'll take them away from you. Right. So we also, like in this case of Colorado Springs. The IT department was really concerned about software and software downloads and merging and stuff, and they really calmed down when they realized it's just a web browser and they can just pull data in Excel format from there. It really calmed down their security department when they realized that's what it was. It wasn't going to be a software license and back-end access into their network. That's what really got them paranoid, and that would keep any IT department paranoid, especially just recently what we saw with pipelines, right? So you don't have to worry about that. And it's user configurable. So you're not just getting a pre-spit out Excel format. You can actually decide what parameters you want to download. So you're not just getting everything. You can just get what you really need from it. And you can truly access it from anywhere, anytime. Once again, if you're on a mobile platform and you have a connection and you can get on the web and you can access your site on SiteView, you can actually view your data. So now we're going to move to a demonstration. We had a little issue just recently with the internet, so we're going to see if we can get this going. So right now I'm going to go ahead and grab this, and so we'll just go ahead and drop this down. And I need, I believe, kill the PowerPoint to do this. Okay, so that's done. Okay, there we go. I'm going to go. All right, and I'm going to get over here and see, make sure I can share this with everybody. Is that showing online? Okay, perfect. Okay, so I'm going to go ahead and enter my email. Write this down if you have questions for later. And we're going to be brought into our SiteView site here in just a moment. I'm connected to a lot of devices, so.
Computer's not going to really slow.
And this computer is running a little bit slow today, so it'll just be a minute here. You got the arrow back, so we're getting closer. connected to the internet. I apologize it's taking so long. It's clearly our internet connection is having a little bit of an issue. Maybe that was, no. Let's see here. There we go. I think we had a pop-up box that was locking things up there. Yeah, I don't know. I'm gonna try Internet Explorer. Just see if maybe Chrome's the bugger right now. Here I was just joking about Explorer, right? Let me get that up. Okay. Let's see here. That seems to be operating quick. Oh, it just loaded? Yeah. See, Chrome got offended I was going to Microsoft. All right, so right here, we're going to look at one site right here. This is a waste management site, and we have one device found. So right here, I have my box, and I click on my box. And this is our view, what it pops up. Notice over here, I can manage my devices, and I can manage my users. So I can look at my devices, if I have a list of devices, and sort those. I can manage my users. There's two levels of access on site view, administrative and user. Administrative gives you the rights to go in there and make changes. User, you can view the data, right? So you can just use it to grab data. Right here on our dashboard view, we have the submersible up here. We can look at our activity. Last activity was 9 minutes ago. Device version, cloud version, but right here, we get voltage on the Site Pro, device temp, any faults, any alarms, any other switches, and then a well alarm or tank alarm. So this is the dewatering site. We have our depth, water level depth, and our tank depth. We have a forecast, and we also have where's the box on site. So we have a map view. So if we have to go out there and find the box, we haven't been out there previously, gives us an idea of where to go find it, right? I'm going to go back up and we'll look at a couple more tabs here. And click on status. Clicked on status, it's waiting. Bless you. I wonder if Google's running updates today or something. And keep working on this one too. Oh, that's. I try to reload it, but when we go to status, this is where we actually get our sensor data. Like I apologize, clearly we're having web connection issues today, so, and that's just on our end. Well, I'm going to take you guys down through this. So status, this gives us a idea of all of our sensors on site, and will actually allow us to view all of our sensors, gives us actual data in bubbles, and then also has actual real-time graphs leading up, to what the most current reading is, to what we've collected over time. I tried doing edge as well, and it didn't want to pull up. I'm just going to go ahead and restart it. Here we go. All right, so there's dashboard. I'm going to click on status. Google's just having a hard time walking and chewing gum today. Yeah, it's clearly on Google's end if we're getting that error on the screen. Let's see if we can get this other one working. Seems like it wants to work now. Huh. I apologize. Yeah, this is frustrating when you're trying to do a live demo and, always the risk, always the risk, right? So let's get back to at least dashboard here. For sake of time, we got to move forward. I'm gonna see if I can get off this and go to a wireless connection. Well, I apologize, everybody. It looks like internet's just not working on this laptop today, so I really apologize. You know, so, oh, there we go. I say that and look what it does, right? I swear these computers listen to you.
Not wrong.
Yeah. I mentioned something about a barbecue grill recently, and it popped up on my phone the minute I accessed the internet. Let's try maybe a different site. See if that pops up. That internet's really slow for some reason. I apologize.
Probably because everybody's on your network.
I think
On their
so.
phone.
Yeah, I think we have 1,000,001 phones on our network right now, and I would try to hotspot on my phone. I just got to find the Wi-Fi thing on here. And let's see. And I am blocked from turning on the Wi-Fi. So I am only connected to that. Let's see here. Hey, Andrew, can you find Raymond, please?
Yeah,